Yes, good morning all of you. In this video, let we solve the problems. Exercise number 2.2, second problem. I hope you might already seen my last video. We solved a few problems. Actually, exercise 2.2 first problem. Now we can enter to the second problem. Now in the second problem, what is the question they asked me here? Find a quadratic polynomial each with a given number as a sum and product of its zeros respectively. Actually, in this problem, they given a sum of the zero value and product of zeros value. That means sum of the zeros alpha plus beta, the first value, then second value alpha into beta. Are you clear? So they given a sum of zeros and product of zeros. Now we can use this to find out the quadratic polynomial, right? Are you all clear? So let me enter to the problem. First question. So the sum of zero they given, that is 1/4. So that means alpha plus beta is equal to 1/4. Next, product of the zeros 1. That is alpha into beta is equal to 1. Now the quadratic equation of the form x squared minus alpha plus beta whole x plus alpha into beta. That means every quadratic equation of the form, when we write the quadratic equation in terms of zeros, it can be written as x squared minus sum of the zeros into x plus product of the zeros. That means the sum of the zeros will be the coefficient of x and product of the zeros, here it is constant in quadratic polynomial, right? So the form is x squared minus the sum of the zeros, that means alpha plus beta the whole x plus product of the zero, that is alpha into beta, which is equal to 0. Very well clear? So you just keep this x squared minus alpha plus beta the whole x plus alpha into beta. Here the more important is minus value, that is x squared minus. So the in this form x squared minus alpha plus beta the whole x plus alpha beta equal to 0. In this problem, that is more important. This step only the more important. So only repeating again and again. Okay, next, as usual, x squared minus alpha plus beta. They given sum of the value alpha plus beta is equal to 1/4. So alpha plus beta, that is sum, that is 1/4 they given here. So 1/2x. Next, product of the zero, here they given 1, that is minus 1, which is equal to 0. So next step, here is coefficient of x they given 1/4. So it is in a denominator form. Let me multiply the whole equation by 4. So now we can get it 4 into x squared, that is 4x squared, minus 4 into 1/4x. So 4 can be cancelled. So remaining 1, so 1x minus into plus, so minus 1 into 4, so minus 4 equal to 0. Very well clear? Next question. In this problem also same thing. Sum of the zeros √2, product of the zeros 1/3. Now we can write the general form. The quadratic polynomial of the form x squared minus alpha plus beta the whole x plus alpha beta. So alpha plus beta they given √2. So minus √2x plus product of the zeros 1/3. So 1/3. Now 3 is in the denominator. So what you can do? As usual, multiply the 3 by whole equation. So 3 into x squared, 3x squared minus 3 into √2x, that is 3 √2x plus 3 into 1/3, 3 cancel 1, which is equal to 0. That is 0 into 3, it means obviously we know that it is 0. I hope you are all clear. Next question. In this problem, they given the sum of the zeros 0. Next, product of the zero √5. So the quadratic polynomial of the form x squared minus alpha plus beta x plus alpha beta is equal to 0. So x squared minus sum of the zero they given here 0. So 0x plus √5 equal to 0. So x squared 0 into x, it became 0. So minus of 0, 0. So plus √5 equal to 0. Very clear? Next question. Sum of the zeros 1, sum of the zeros 1, product of the zeros minus 1. Sum of the zeros 1, here product of the zeros also 1. So the quadratic polynomial of the form x squared minus alpha beta the whole x plus alpha beta is equal to 0. Instead of alpha plus beta, you can substitute the value 1, because sum of the zeros 1. So minus 1x plus 1 equal to 0. So x squared minus x plus 1 equal to 0. Clear? Remaining two problems, actually 2.2 second problem, fifth one and sixth one. You should try yourself. If it is any doubt, you can ask me in comments. Thank you all of you.